Good morning, dear viewers. Welcome to Password Science channel. Today we shall be treating the just concluded NECO chemistry past questions. So let's get right into the business of the day. So according to the question here, we are told to answer all the questions. Say all your Bouré readings, initial and final, as well as the size of the pipette must be recorded, but no experimental procedure is required. All calculations must be done in this question paper. Alright, so we're given that A is a solution containing 0.15 mole per dn cube of HNO3, that's triazonitrate 5 acid. Alright, so the only way we can arrive at this value for the molar concentration of the acid is if we use a percentage assay or concentration of 70%. That is because the volume of the acid given in the guideline released by NECO is 9.5 cm cube. Alright, so that is the only way we can arrive at this value. And B, we are told is a solution containing 4.20 gram per dm cube of X2CO3 salt. So put A into the burette and titrate against 20 cm cube or 25 cm cube portion of B using methyl orange as an indicator. Repeat the titration 3 or more times and record your results in the table below. Volume of the pipette. Right, so here I'm going to put the volume of my pipette to be 25.00 cm cube. Okay, so for this particular work I'm still going to use my previous values, the values I have in my table of readings which I uploaded before. Alright, so here I have that my rough is 14.80, and then the first titer is 14.50, then I have the second one to be 14.40, and then the last titer to be 14.30. okay, let's say my initial going to be faster now. Okay, so from there now, if I work this out, I am going to have here is a 14.80, 14.50, 14.40, and 14.30. Alright, so A says calculate the average volume of A used. So average volume of A is going to be equal to my first titer plus second titer plus third titer. Everything is going to be divided by 3, so that is going to give me 14.50 plus 14.40 plus 14.30 all over 3. So if I work that out, I'm going to have that's going to be equal to 43.20 all over 3. So that will give me that my VA is equal to 14.30 0.40 cm cube. All right, so that is what I have for my average titer. So now go on to the B part of the question. So the question for the reaction is as given in that place. So from the result and information provided, BI says calculate concentration of B in mole per dm cube. So concentration of B in mole per dm cube. There are two ways we can do this. The first one is to use the mass concentration all over the molar mass, but we cannot use that particular formula that says mass concentration. We cannot use we cannot say that CB is equal to mass concentration all over molar mass. Reason we cannot use this is because the molar mass of B is unknown because the value of X is not given. So the other formula we can use is what we call the mole ratio formula. So using the mole ratio formula, the mole ratio formula we have that CA VA all over CB VB is equal to NA all over NB. Now we have that our CA is equal to 0.15 mole dm cube, and our VA is equal to, we just calculated that to be 14.40 cm cube, and then our NA we can get that from here. NA is 2 from the equation here. So we have that NA is equal to 2. Then we have that V okay, before that NB is equal to 1. Then we have that VB is equal to, that's the volume of our pipette, 25.00 cm cube. So now we are looking for CB. CB is unknown, so substituting all of that into the equation, we are going to have that 0.15 times 14.40 all over CB times 25 is equal to 2 over 1. Okay. So that is going to give us, we're going to have CB is equal to 0.15 times 14.40 times 1 all over 25 times 2. That will give us a CB is equal to approximately 0.04 mole per dm cube. So that's what we are going to have approximately. All right, so now the next thing there is to calculate our molar mass. So to calculate the molar mass, we have that the molar mass of B is equal to the molar mass of B is equal to the mass concentration in gram per dm cube all over molar concentration in mole per dm cube. So that's what we are going to have there. Molar concentration of B is equal to mass concentration in gram per dm cube of B over molar concentration, and we have that our the mass concentration is what, 4.20 gram per dm cube all over the molar concentration, which is 0.04 mole per dm cube. So working that out now, molar mass of B is going to give us we have approximately 105 gram per mole, 105 gram per mole. So that's going to be the value of molar concentration. So from there now we move on. So we should calculate the value of X. For us to get the value of S, we have the molar mass of B is equal to 105. That gives us that that gives us that X2CO3 is equal to 105. That will give us that this is the same thing as saying 2x plus C is 12 plus O is 16 times 3 is equal to 105. So this is going to give us 2x plus 12 plus 16 times this is going to give us 48 is equal to 105. So if we work it out, we're going to have we're going to have 2x plus 60 is equal to 105. So we have that 2x is equal to 2x is equal to 45, and then x is equal to 22.5. So that is the value of our x. Sorry about that. So the value of our x is 22.5. So it states two precautions taken in order to obtain accurate reading from the pipette. Number one, I ensured that no solution was spilled when transferring the content of the pipette. Or you can say during pipetting. 2, I ensured that air bubbles did not enter the pipette. Another one you can say mistake. Sorry, this is a mistake. This is supposed to be in this column. Alright, sorry about that. So the 2 precautions: number 1, I ensured that no solution was spilled when transferring the content of the pipette. 2, I ensured that I did not allow air bubbles into the pipette. 3, you can say I avoided parallax error when taking my pipette readings. Alright, so the next question here says, what will be the color of the indicator in B and at endpoint? So here you see 1, color of indicator, in solution B is equal to what? Yellow. Number 2, color of indicator at endpoint is equal to orange. Alright, so we are done with this question on titration. Alright, so B says B is on SWOT analysis or qualitative analysis, and here we are provided with 2 samples, X and Y. It says put a little portion of sample X into a test tube and heat. Test for any gases that may be involved. So what will be the observation? Effervescence occurs. A colorless effervescence, a colorless and odorless gas is evolved. gas turned lime water milky and blue litmus paper red. So that will be the observation. When we put a little portion of sample X into a test tube and heat, we're going to have that a colorless and odorless gas is evolved. The gas turned lime water milky and blue litmus paper red. So we say here gas is acidic. Gas is acidic. Full stop. Gas is CO2 from CO3 2 minus. So that will be the inference. They say heat the portion strongly above and allow to cool. So the observation will be yellow when hot and white when cooled. So that will be the inference here will be zinc oxide is present, because that's the only oxide that is yellow when hot and white when cold. Then B says dissolve sample Y in about 5 cm³ of distilled water, shake thoroughly, divide the solution into two portions. So what will be the observation? When you add 5 cm³ of distilled water to Y, you are going to have that Y dissolves to form a clear solution. Y dissolves to form a clear solution, and the inference is that Y is a soluble salt. Okay, then the next one says to the first portion add dilutes sodium hydroxide solution in drops and in drops. So when you add in drops, you are going to have white gelatinous precipitate is formed. So the inference here is that the only two ions that can form white gelatinous precipitates are zinc ion and aluminium 3 ion. Don't include lead, because lead forms a powdery or chalky precipitate, not gelatinous. So say present. Then say in excess, when you add in excess white precipitate, dissolves. So white precipitate dissolves means that still the same thing, zinc ion or aluminium ion present, because these two ions will always dissolve in excess sodium hydroxide solution. Then the next one, say to the second portion add dilutes ammonia solution in drops, then in excess. So when you add in drops, you're also going to have the same thing, white gelatinous precipitate is formed. So the same thing here, zinc ion or aluminium ion present. So that's still the same thing that we have there. And then when you add in excess, white precipitate persists, or say does not dissolve. So when you add in SS, white precipitate persists or does not dissolve. And what is the inference? The inference is that aluminium ion is present. Still confirmed, because aluminium ion does not dissolve in SS ammonia solution, but zinc ion does. Alright, so that is that for that. Then the next question says, what is the effect of adding sodium chloride crystals on the boiling point of water? The effect is that it raises or increases the boiling point of water, and not just water, and not just sodium chloride, rather the presence of any impurities at all will always raise the boiling point of water. Let's mention one characteristic of boiling. So the first one is that boiling occurs at a specific fixed temperature called the boiling point. Then the next one is that boiling occurs when the saturation vapor pressure equals the atmospheric pressure. Right, then we also give one reason why the standard solution of sodium hydroxide cannot be prepared by weighing out accurately a given mass of the solid salt and make it up to the required volume of solution. Sodium hydroxide is actually a base, not a salt, so I think there is a mistake there from WAEC. Alright, so the reason is that, say, because sodium hydroxide solid, not aqueous, is deliquescent. So the reason is because sodium hydroxide solid is what? Deliquescent. And what that simply means is that when you expose it to the atmosphere or to moisture, it will absorb moisture and dissolve to form a solution. So the absorbed moisture is going to add to the weight or mass of the base, the sodium hydroxide. So for that, we cannot use it in preparing a standard solution. Alright, so one reagent for, we have a quicklime stroke calcium oxide. Alright, to test for what I use either anhydrous, copper 2 sulfate, so it is white when anhydrous, but by the time water is added to it, it turns blue. You can also use anhydrous cobalt 2 chloride. This one is blue in color, but when water is also added to it, it turns pink. So this one will turn to blue, while this one will turn to pink when water is added to it, blue and pink. Alright, so the next one says, name one gas that cannot be prepared in open laboratory. Any poisonous gas: ammonia gas, hydrogen sulfide, sulfur 4 oxide, chlorine gas. These are all poisonous gases, so you cannot prepare them in the laboratory. All right, then the next, even hydrogen chloride gas also. So give one use of each of the following apparatus in the laboratory. Separative forel used for separating two or more immiscible, that is liquids. There's liquids that cannot mix, and usually they have different temperatures. So say one use of the gas jar for storing, for collecting and storing gases. So that's what we use it for in the lab. All right, and with that we have come to the end of the CS NECO practical questions. Thank you very much for watching. Please don't forget to like and subscribe to our channel, Passwell Science channel. God bless you all for watching.